Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
Up to this point, I've been demonstrating static DLL linkage with the application. That's using an import library. In this case, we created with implib, could have been created with the coff to OMF utility. But what this means is that if the DLL does not exist, either in the directory where the application is or somewhere in the search path of the system, then the application won't run. So let's show what that looks like. So I'll just delete the DLL and try to run it. And we get an error saying that it can't find that DLL. So this is static linkage to the DLL. The application is permanently dependent on the existence and of that DLL, and that it has the symbols that you need in it. Any functions that you call in your code have to also exist in that DLL. If it's possible that that DLL may not exist or it may not have the functions you need, and you want your application to still run, then you'll want to use dynamic DLL linkage. So that's going to be the topic of this segment, how to dynamically link to a DLL. So to do that, we're going to take this import library out of our project. We're going to need to create, well, the easiest way to define a function pointer is with a type def. So I'm going to create some function prototypes which match our DLL functions that we've exported. Okay, so we'll do test, just the test call here. Returns an integer, DLL call, takes a struct, test pointer, and a size underscore t. So we'll call this test func underscore t. We need to make sure that this function signature matches this here. When you press the button, we're going to try to load the library. You do this using the Win32 load library function, which returns an H instance. And then you give it the name of the DLL. And it's going to look in the current working directory and the search path for that DLL. If hinst returns null, that means failure, so we're going to check here that the load did not fail. Actually, what we can do is, if it fails, display a message box. Application message box. Let's see. So we'll include windows.h. And then it's giving me a warning about : test. So what I need to do is create a test func underscore t test equals, and then so this is in the success case. I'm going to call the Win32 function, which we'll have to typecast the return value of, get proc address, pass it the hinst handle, and then the name of the function that we're trying to get. In this case, it's called test. And then we should be able to just call it here without the : Oh, now we have two symbols called test. That's not going to work. Go ahead and put it like this. Test func, test func. That way we don't have both a structure and a function with the same name. Okay, so these need to be wide characters. Let's see, underscore T, I believe. So I'll have to remove this get size call. Unless I do the same thing up here for get size. For now, I'll take that out. So again, I deleted the DLL, so it should fail when I click this button. Yeah. So I got that load library failure error. Now, so let's go ahead and build the DLL so it exists again. And it's in the same working directory as the application. So now when I click that button, it should be able to find it and load it. I have a breakpoint. Oh, didn't like that. Okay, so the issue is I'm not checking the result here of get proc address. So it looks like get proc address is probably failing. Okay, so get proc address is failing. It's not finding the symbol test in the library. Let's take a look at that library. tdump /c debug dc test. All right, and the symbol underscore test at 8 looks to be the symbol name. And the 8 comes from 8 bytes on the stack that's being passed to the function. So that's part of the name decoration used by Microsoft for standard call functions. Okay, so it got the test function pointer. Good. Calls it, gets a result. Result is 0. Hooray. So if you wanted Visual C to generate names without this decoration, you would need to use the cdecl calling convention. So I'll go ahead and revisit that now, and we'll change our calling here to cdecl. So let's look at the symbols again. Yeah, now our symbols are in here, and it's just test. There's no at number. And then rebuild this guy. No leading underscore, no at, no number. Okay, and it works. So you can use either calling convention, but it's important that the application and the DLL both agree on what the calling convention is going to be. So let's say that you only want to do the load library call once. What you probably would want to do is create one of these H instance variables in the class definition for the form or the application, or whatever scope it is that you're going to be often dealing with the functions in the DLL. So we'll just call it DLL HInst. Make it a little clearer. So that way we're only loading it once, even though we might call get proc address multiple times. Let's say we want to do the get size. We want to add a way to dynamically call that get size. So again, a function type def comes in handy. So I'm going to add it here. Just it's easy to keep them synchronized. It returns the size underscore t. We need the DLL call macro, which is now cdecl, not standard call. call it get size func underscore t, and it takes a void. So this is defining a new type of that name, and it's a function pointer with this signature. Returns a size t, has the calling convention defined by this macro, which is cdecl, and takes no arguments. And we don't have to rebuild the DLL. This is only for use in the application, CBuilder application. So get size func underscore t. So we're going to double check that didn't fail, and then we're going to create a get size func type, and then call get proc address, and then the name of the function. And then we'll double check that that didn't fail. The function's got the wrong name, it doesn't exist in the DLL. Then we don't want to dereference a null pointer, as I demonstrated earlier. And then you would want to call the function, set the value. Get size func. All right, so if this works, then those two edit boxes should be populated with the sizes of that structure during runtime. During the constructor, actually during the constructor of the form, and then you'll see it when the form shows. There we go. So this value was populated by this line right here, while this value here was populated here. It called into the DLL and put that value here. And they agree. We already went over that with the structure packing options and pragmas. So that's how you dynamically link and call DLL functions from C++ Builder.